I Know Nothing book reviews, and I'm reviewing books mainly based around cosmology. Um, as a disclaimer, I take no credit for what is written in these books. I am merely relaying their content based on my own subjective interpretation and training as a potential educator, as I'm going to school to become a teacher. The reason I decided to start this vlog is because I love to read, I love science, but sadly, I did not receive scientific training um, despite my love of it. So I've decided to independently take up learning about physics, mathematics, cosmology, and a bunch of other interdisciplinary items that come along with it, which will be explained later on in this review. I am E.M. Lees. So here we go. What is cosmology? For one, it is the study of the universe, mainly its origins. Some of the things that come with this are astronomy, the Big Bang, inflation theories, cyclic theories, which are both theories regarding how the universe started and where it is going. So everyone's familiar with the Big Bang, but not so much inflation or cycles, which we will go into in other reviews later on about cosmology. Space time, which is hilariously referred to as a bread loaf in one of the supplementary materials I'm going to use, basically saying that space time, everything that ever was or ever will be, has already existed or will exist. So everything is pretty much set forth based on how we observe in our actions, but it is still there. And of course, spatial anomalies such as black holes. These are the books that I'm going to review. This is the main one, Cosmology for the Curious by Delia Pervolv and Alex Vilenkin. These are the three supplemental materials. I am a huge fan of Brian Greene. I really enjoy how he explains everything. The Fabric of the Cosmos, The Elegant Universe, and Quadrivium, which is more of an ancient kind of science, particularly when it comes to music, mathematical ratios, and nature, and of course, the alignment of the stars. So, what's of interest? Well, of course, for one, we all live in this universe, we live on this planet, but we very rarely think about the objective reality that is governing everything around us, especially how it affects us and how we, in and of ourselves, can tap into that knowledge and get a much more firm and deeper grasp on this universe. Now, a lot of people I've met they kind of make fun of me for being into these things because they're like, oh, what does this do for us? What does this mean? For me, the reason I study this independently is because it makes me feel one, not alone in the universe. It makes me kind of realize my place as someone who is essentially made of stardust. It makes me understand why things are the way they are, the way I see, the way I hear, the way I feel. And it provides this all encompassing catharsis as to existence itself. So things that are going to come up primarily in the cosmology for the Curious book is Newtonian physics versus quantum physics. Now, Newtonian physics is things that we see on Earth, things that are regarded as macrocosms, so like a ball falling. And why does it fall? Gravity, of course, if you throw it. Force, acceleration, velocity, momentum, things that are governed by larger objects that we can visibly see. Quantum physics is stuff that's smaller than an atom, so like a proton, for example, or even the smaller constituents of a proton, which would be quarks. How do these particles interact to create atoms, and thus how do atoms create matter? Special and general relativity. Special relativity deals with how light travels through the universe, particularly if you're going at the speed of light or even faster than the speed of light, which only the spatial fabric can do. The motion of light through the universe and how it affects someone who has the ability to be aware of their moving through space at such a speed. And then general relativity, which by this diagram here is governing the geometry of the universe through mass. And mass is the reason that space warps and bends. There are other things such as time dilation and simultaneous experience. So time dilation, what happens if we're in a place that has really dense gravity, if a planet is moving faster, how is time perceived? Essentially, how time is affected outside of our own observations as being stuck on Earth, and simultaneous experience of events happening at the same time but observed differently. So everyone's understanding of time is relative to them. Then, of course, geometry of the universe, which goes hand in hand with general relativity. Why does the universe bend the way it does? How is it? Why does it warp? What does mass do? Um, and is there a spatial constituent to the most minute of particles, which we'll get into later, that allows for this bending and warping of space to occur? And essentially, what is the fabric of the cosmos? Observable universe and critical density, essentially the matter we can see, nebulas, planets, stars, galaxies, and of course we're going to go into Hubble, the Hubble telescope, Hubble parameter, basically how the universe expands, the rate is expanding, and what this says about the shape of the universe as well as its critical density. Dark matter, next space, dark matter and energy fields. By energy fields, I mean like electromagnetic field, like the field of where things are observed in light, the strong force field, and the weak force field, which both deal with atomic elements. So, like the strong field is what holds is ruled by the gluons, which are little particles that hold protons and neutrons together inside of an atom, and weak forces like them decaying, so radiation, for example. I'm hoping I'm getting that right. And then we have dark matter and energy, which are elements of the universe that do not interact with the electromagnetic wave. So we can't see them or observe them the way that we traditionally do. And then, of course, just for fun, the mathematics of physics are made easy in this book. For most of my life, I didn't like math at all. I really liked science. I liked physics, but I couldn't understand how to understand the formulas or how to express them. And one book that really helped bring it into context for me was the Quadrivium, as well as a religious text, because I'm Hindu, the Upanishads, where it kind of made me realize everything is one and the same. So I'm just looking at different aspects of the same thing, which essentially is what the cosmos was, according to these books, one constituent element that diversified later on. So here are the supplementary materials. The Elegant Universe by Brian Greene. String theory is one of the most prominent theories in explaining the structure of the universe by combining the quantum world and Newtonian world. Strings have spatial definition, possess tension, energy, and wavelength, and also incorporate gravity. And essentially, we're a cosmic symphony. So another supplementary material is the fabric of the cosmos. So the importance and nature of gravity is explored, particularly that gravity is not just attractive, it is also repulsive under certain pressure, such as what happened just before the Big Bang. Cyclic and inflation theories that touch upon what the most likely origin of the universe is and its earliest moments. And of course, filaments of the cosmos. Are we on a thread? Are we encased in a brain, which is like a legit membrane? We can't actually interact with it because the particles that constitute our own observation and experience are dominated by the electromagnetic field, whereas a membrane, essentially the sticky stuff holding everything together, the literal fabric of the cosmos, can only very possibly be penetrated by the graviton, which is the particle that makes up gravity, which is yet to be actually detected because gravity is such a weak force. It would take very delicate machinery, such as that of a gyroscope in space, or something that measures gravitational influences as the Earth moves, to detect the graviton. And of course, what supersymmetry, essentially string theory, how particles have the mirror image of themselves that is on the opposite end, does the opposite. So like an electron will have a selectron, same far denser mass, same charge, something like that. What does supersymmetry say about the nature of the constituents of reality? And then this is my favorite one because I am super into astrology, believe it or not. Quadrivium, but from Wooden Books. It's a combination of several books. It's nature, geometry, numbers, music, and cosmology. So basically, how we humans have made use of our cosmic observations going back thousands of years, how it's affected us culturally, sociologically, and what has so far shaped our reality. So astrology, music, frequencies, and ratios all have to go into this, particularly with the planet Venus, for example. The ratios of its orbit around the Earth, in retrograde and forward going around, 3, 5, 8, and 13, I think. Yeah. Have all been very influential in music ratios, as well as the Fibonacci sequence, which rules about 97.5% of all patterns in nature. So tune in next week for my chapter reviews of Cosmology for the Curious.